So for this week, we're going to first start talking today about the fundamental trig identities. There are 8 of them. So today I'm going to tell you what they are, and I'm going to show you how we can use them to simplify expressions. Okay? It gets better tomorrow when we can actually use our trig identities to verify a problem. Okay? So Tuesday, Wednesday, and Thursday, we're going to be verifying identities. Okay? And then we'll take a quiz on Friday. So what we do today, this is the foundation for all week. Okay? You actually know 5 of the 8 trig identities already. Okay? The first set are called the reciprocal identities. Reciprocal identities. We're talking about trig. And I just threw out the word reciprocal. What comes to mind? Secant, cosecant, cotangent, right? We know that the cosecant of theta is the same as 1 over sine theta. We know that the secant of theta is the same as 1 over cosine theta. And we know that cotangent theta is the same as 1 over tangent theta. And those are your 3 reciprocal identities. Now, technically, we could also say, and these are just kind of these are just the same things rearranged. We could also say that sine is 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. I'm just throwing those up there because those could be beneficial. They are the same thing, they're just rearranged a little bit. And so technically we have these 3, but we can think of them as 6 if you'd like. All right, the next set of identities are called the quotient identities. Quotient. If we're talking about trig functions, quotient means what? Dividing. Which trig function or which trig functions are the quotient of maybe 2 other ones? There it is, tangent and cotangent. We know that the tangent of theta is the same thing as sine theta divided by cosine theta. And then our cotangent is the same thing as cosine divided by sine. Okay, so there's the 5 that really we haven't talked about anything you didn't know already. Okay, so those are your first 5. The other 3 identities are what we call the Pythagorean identities. What do you think they're based off of? The Pythagorean theorem. Okay, I'm going to draw a picture that you do not need to draw, but this is just to show you where it's coming from. I repeat, you do not need to draw this picture. But imagine the unit circle. That's not a bad circle. Kind of proud of that one. If we have a coordinate on the unit circle, x comma y, how did we get the x coordinate? What did we use on the unit circle? or what did the x-coordinate stand for, I guess? The cosine of the angle, right? And the y stood for the sine of the angle. So this, instead of x comma y, we could write as cosine theta comma sine theta. Okay? Well, if the x distance is the same as cosine theta, and the y distance is the same as sine theta, and our hypotenuse is 1, then when we use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, we can write sine squared theta plus cosine squared theta equals 1. Okay. Now, there are going to be two other ones. I am going to write them first. I'm going to skip a little bit of space. You don't need to do that on your paper. Okay? I'm going to skip a little bit of space so I can show you how I get these. But for right now, I just want you to write them down. 1 plus cotangent squared theta equals cosecant squared theta. And then tangent squared theta plus 1 equals secant squared theta. Write those down and I'll show you where they come from. Okay, so technically, I have one identity up here that I've rewritten to get these other two. Okay? If I take this identity up here, and I don't want you to do this with me, I just want you to watch, okay? If I take this identity up here and I divide everything by sine squared. I divide both sides by sine squared. What is sine squared divided by sine squared? 1. Cosine squared divided by sine squared. Cotangent squared. And then 1 divided by sine squared gives us the cosecant squared. Okay, so it's the same identity, just rearranged a little bit. Okay. Now imagine doing that, except this time we're going to divide by cosine squared to both sides. Okay. Well, sine squared divided by cosine squared gives us the tangent squared. Cosine squared divided by cosine squared gives us the 1. And then 1 divided by cosine squared gives us the secant squared. Okay. You should know these, right? And really, we've done enough work with the unit circle. You should know these. If you don't, they need to be in your memory. But what you need to work on this week is knowing these and being able to write these at the top of your paper so you can use them in a problem. Okay? You must know these 8 fundamental identities in order to do what we do the rest of the week and next week. Okay? For the entire chapter. Okay? These are identities, which means they're true. Right side equals the left side. Okay? We don't need to prove that they are true. I mean, I kind of went through and showed you why these are what they are. We worked with the unit circle to where the first 5 you kind of understand from our work there. But we just need to take these as facts and we need to use them to help us. Okay? Now, before I show you some things that we can do with them, I want to practice one thing first. We need to be able to remember how to factor, but now we have trig equations that we're going to have to factor with. So I'm going to go through 2 problems to where we would have to factor, okay? Right now, I want you to just write this down, and I'm asking us to factor this trig expression. On Friday, I'm going to teach you the introduction of solving trig equations, and we're going to have to be able to factor and set those factors equal to 0, okay? So one thing I want you to remember is that what pattern is this? What factoring pattern is this? A squared term minus a squared term. What do we call that? So it's 3 words. The second word is of. What's the word for subtraction? We need a synonym for subtraction. Difference of squares. This is a difference of squares. And when we have a difference of squares, we factor a minus b times a plus b. Okay, but instead of using a's and b's, for x's and y's, we're using cosine and sine.
So the top one is the difference of squares equation, or?
So this is just like the very basic difference of squares. I just wrote up here to remind you. Since we have cosine squared minus sine squared, we have this pattern, and so we can use it to factor it out. Like instead of a and b, I have cosine of x and sine of x. Like, I have a squared term minus a squared term. Here's just very, very basic. Anytime we have a squared term minus a squared term, we take first minus second times first plus second.
Okay,
Okay. I also should come back to here and note any of these identities. Do you notice how here I had thetas? And then all of a sudden I had x. It does not matter what your angle is. Your angle could be 15. Your angle could be z. As long, whatever your angle is, as long as it's consistent throughout your identity, it will work. Okay, so these work as long as the angles stay the same. Okay. All right, one more factoring problem, and then we will use our identities to help us. All right, what does this look like? Okay, it looks like a trinomial, doesn't it? Like if we had 4x squared plus x minus 3, like we would feel really good about that. But it's 4 tangent squared x minus plus tangent x minus 3. We are not going to approach this any differently, okay? Just instead of a variable like x or y or t, we have tangent of x. So if this like overwhelms you, let's do this. Let's just call tangent t, and let's focus on the polynomial version first. If you had something like this and I asked you to factor, right, we would have to do this. Okay. What is this factor? So 4t times t could get us the 4t squared. And then to get negative 3, what are you thinking? Well, negative 3 times 1 is definitely negative 3. But if we do our inside and outside, 4t times 1 and 3 times t, does that get us what we need for our middle term? Okay, well, I don't really want t's, I want tangents. So instead of this, what I really want you to write is that this factors to 4 tangent x minus 3 times tangent of x plus 1. Okay? Really, instead of t, we can just turn those back to tangents. Okay? Now, you don't have to do this right here if you can see how it factors without it. But if I'm asking you to factor and those trig functions are overwhelming you, change them to just a letter, like S for sine, C for cosine, whatever it may be, so that you can use more of your polynomial processes to help you with that. Okay? So I can't remember if they're like towards the beginning or towards the end. But you will have a handful of problems that say factor. Okay? A good chunk of your problems are going to have this instruction. Simplify the trig expression. Okay? So in your notes, write simplify so you know that that's what we're doing. Okay? Whereas the other two problems, if you want to write factor next to them, so you know that that was the instruction. But here, I'm asking you to simplify a trig expression. So what we need to do, we need to use a combination of algebra and those trig identities that we wrote on the first two slides to help us rewrite this into something that's quote unquote simple. Okay? So just like I ask you to do with any algebraic problem, it is always a good idea to look for an opportunity to factor. Okay? Do we have an opportunity to factor here? What can we factor out, Veronica? Okay, we have two terms, and both terms have a sign of x. So what we can do is we can take this sign of x and we can factor it out, which means left over here is just 1 minus left over here is cosine squared. 1 minus cosine squared. Do we have something that we wrote down that has a 1 and it has a cosine squared? Jacob, what did we write down? What is the identity that you're thinking about?
The reciprocal identity is you have 1 over the cosine.
Okay. In this right here, is this a fraction? No. So while yes, the reciprocal identity has a 1 and it has a cosine, but there's no subtraction there, right? Is there a different identity with a 1 and a cosine? Okay, this is something that you have written down, right? It is okay to rearrange these just a little bit. So what would have happened if I took cosine squared and I moved it to the other side? We would have 1 minus cosine squared. Do you agree? So what we can do is we can take 1 minus cosine squared of x and we can replace it with sine squared of x. So first we factored, then I used the Pythagorean identity. Okay, that's what we used there. Well, now what is sine times sine squared? Sine cubed. So So we can multiply to get sine cubed. I'm just kind of making a little note to the side of what we're doing in each step, so you can kind of, if you need to reference back, you know what we're doing. Questions? Let's try another one. Go ahead and write this one down. My advice to you would be to have your notebook open to this page when you're doing your homework, or write down those trig identities on a note card that you use when you're doing your homework so they can be in front of you so you can look for opportunities. Okay? All right. Sine of x plus cotangent of x times cosecant of x. We need to simplify this. What is maybe a simple step that we can do to help us get going? Does anybody have an idea? Could we make cotangent into cosine over sine? Is that a possibility? Okay, let's do that. Cotangent is the same thing as cosine over sine. Okay, that's our quotient identity. Okay. Well, now I have kind of a fraction times cosine, right? So maybe let's just make that look a little bit nicer. We have the sine of x plus cosine squared over sine of x. Okay. Well, I have a fraction that I'm adding to something else. Okay? If we had numbers, if I had a fraction plus something else, what would be important to do before we added them together? A common denominator, right? Well, no different here. We need a common denominator. So if this has a denominator of sine of x, all right, then we need to take this and we need to make a common denominator. So since our denominator is sine of x, we need to multiply this over here by sine of x over sine of x. Okay. So that when we actually add these two fractions together, okay, this numerator is sine squared x. This numerator is cosine squared x. And our common denominator stays as sine of x. Ryan, on your paper somewhere, did we write down something like sine squared plus cosine squared? What does that equal? 1. Sine squared plus cosine squared. When you see that, you should celebrate, okay? Sine squared plus cosine squared we can replace with 1 because that is one of our Pythagorean identities. And then Brecken, what is 1 over sine of x the same as?
1 over... Oh wait, no, that'd be cosecant, right?
Yeah, so what's 1 over sine of x? Yeah, which would be cosecant, is that what you're saying? Mm-hmm. Yes. So cosecant of x because of our reciprocal identity, we have now simplified this expression all the way down to cosecant x. Yes?
You explained how you got the common denominator part, like
Yes, so since we are adding and one of our expressions is a fraction, we have to have the same denominator in order to add them together. So since this had a denominator of sine of x, then we had to multiply this by something with a denominator of sine of x. But we can't just multiply and change the value. We have to multiply by 1. Okay? So we multiplied by sine over sine so that we would have the same denominator, but we didn't change the value. So then sine times sine is sine squared. And then this is where I got that. Okay, cosine squared gets to stay there, but then when we add them together, we can just smush them to be one big fraction.
Okay.
Yes? Okay. Other questions about this? Okay. Some of you may be thinking, how did you know how to do all that? Like, how did you know where to go? Okay. That is something that is going to take some time. And so I understand that today's assignment could be a little bit slow going in terms of knowing maybe what to do first, maybe what to do second. I need you to attempt every problem, but I also need you to understand that it's going to get better tomorrow because we will have like a definite, this is the end of the problem. Some of you may struggle knowing like, well, am I all the way simplified? Okay. Some of you maybe wanted to stop here. Some of you maybe wanted to stop here, not knowing where to go next. I get that. We have to practice using these before I show you how to verify an identity tomorrow. But just be patient and know that tomorrow you will have a definite, yes, I have finished the problem. Okay. I want to go over this one so I can show you a strategy that can be helpful. Okay, so we'll have this example and then something called trig substitution and we'll be done. Okay, but like I said, as you're writing this problem down, you are really going to need to bring your patience pants when you do your homework assignment and know that it's going to get better tomorrow. Okay? So here we go. I don't really like that I have 1 plus sine of x in the denominator. Okay? And what we're going to do, we're going to use a strategy called multiplying by the conjugate. Okay? You've heard that word before, right? Conjugate. We've talked about that in here. What would the conjugate of 1 plus sine of x be? 1 minus sine of x. So let's go ahead and multiply by the conjugate. And we can't just multiply the denominator. We would have to do numerator and denominator so that we're not changing the value. We're multiplying by our well-chosen 1. Okay. So what we get is we have 1 minus sine of x in the numerator, but then our denominator is 1 minus sine squared x. Okay. 1 minus sine squared x. Okay, same thing that we did before, right? We know that sine squared plus cosine squared equals 1. So if we rearrange this, we can take 1 minus sine squared, right? Take this sine squared, move it over, and that's the same thing as cosine squared. Because of our Pythagorean identity. So some of you are like, well, how, like, are we done? How do you know when we're done? You know, just be patient. I would encourage you to, if you can help it, not leave your answer as a fraction. All right? Until we know more about what we're doing tomorrow, I would encourage you to try, if it's possible, not to have a fraction. So since we have a denominator and we have more than one term in the numerator, we can split this up. 1 over cosine squared minus sine over cosine squared. Okay. That is mathematically legal, right? Okay. Well, what did we say 1 over cosine of x was? The same as secant. So this is just secant squared. Okay. Now I'm going to split this up a little differently just to, some of you are probably going to be able to do this in your head, okay? But I am going to write this as sine over cosine times 1 over cosine. Basically, I'm just cosine squared. I'm writing it as cosine times cosine. Okay, so that we can see that sine over cosine is tangent and 1 over cosine is secant. And at that point we can stop. Now there's one more thing I need to show you that's super beneficial when you get to calculus. And we only have about 3 minutes, and so I'm sorry if I have to rush through it a little bit. But go ahead and this is what I want you to write down. I want you to write down this. And I want you to write down this. The purpose of today is just getting you used to using these trig identities. So here's another way that we can use them. Okay. So if x is the same as 2 tangent theta, then we can put 2 tangent theta in for x. Well, wouldn't that be the same thing as 4 tangent squared? What do both of these terms have in common? A 4. Now, since there is addition, I cannot take a square root yet. It has to be multiplication or division. So what we can do is we can factor out the 4. Jack, what do we write down? 1 plus tangent squared. What does that equal? 1 plus tangent squared is the same thing as secant squared. Now we can take the square root. Please be very patient as you're doing your homework. Try every single bolded problem on your gold sheet. Try it. Attempt them. See what you can do. We will talk tomorrow.